All right, now let's start looking at part B. Part B, they gave us a different function, and it says the radius of the first circle is modeled by this function. So the W of t function gives me the length of the radius at any time t, for time is between 0 and 6 seconds. At what time t, so that's what we're solving for, is the radius of the circle increasing at a rate of 3 centimeters per second. Okay, so that means they want to know when is dr dt, it's a rate that they've given us, increasing, so it means it's a positive 3 centimeters per second. Well, if all I have is an amount function right now, I don't have a value for rate. In fact, this is really w prime of t. I called it dr of dt because that's sort of the same variable we used here, and that's probably what we think of when we think the radius is changing with respect to time. But if I'm using the same function notation they gave me in the problem, what they really want me to find is this notation. All right, so the derivative, the rate at which the radius is changing, the derivative of 12, it's a constant, so that's just 0. Here I have to use the chain rule. So first we have a constant multiple of negative 12. Derivative of the outside, okay, so that is just e to the x power, right, with respect to the inside, times the derivative of what's inside. Make sure you keep this as the exponent. The derivative of this linear term is also just a negative 0.5. We can put these things together, so w prime of t, negative 6 times negative 1/2, excuse me, negative 12 times negative 1/2 is 6, e to the negative 0.5 t power. And now they want us to solve for t, right? At what time t is this happening? So now we're going to plug in the rate value that they gave us and solve for t. So the first thing I'll do is divide both sides by 6. All right, so here we have to remember inverse operations. If I have e, an exponential function, the natural number, what am I going to do to both sides to get the variable t by itself? And many of you knew correctly that the natural log undoes the power of e. Okay, that's a Math 3 review. So we have the natural log of 1/2 is equal to negative 0.5t. So then we are solving for t, so we just divide by negative 1/2. Now, when I did my original work, I left it like this. This was originally a non-calculator problem. However, you're allowed any type of calculator during this 45-minute test, so you could quickly plug this in and give it a decimal value. Or you could also use logarithmic rules. I think, let me see, the decimal value isn't on here. The way that they simplified it on the scoring rubric is using logarithmic rules, but I'm just going to leave my answer like this. Instead of dividing by 1/2, I'm going to leave it as multiplying by 2. So I'm going to say t equals, let's see, 2 ln of 1/2, something like this. That is correct. We can label it seconds. Now, you might notice that's not going to match exactly the logarithmic value that they have on the scoring rubric. Or you could leave your answer like this. Or you could leave your answer as a decimal, which was 1.3 something. I don't have it in front of me right now. All correct forms of equivalent forms of correct answers are correct. So there are many different final answers you could leave here. One thing they don't want you to do is oversimplify it so that you get it incorrect. Here is our answer for part B.